How do we use AI or ML tools to be able to do this? Well, in this particular scenario, there's a lot of uncertainty because you don't know where the whales are. You can detect them when they're under the water, they vocalize, and so our robots can sense the direction that their vocalizations are coming from. And so our algorithms will then take that information and whatever other information might be available. So if the whale has a tag on it, when it comes to the surface, that tag gives off very high frequency pings, but sometimes it's not tagged. So the autonomy module, what we call the autonomy module, it's a computer that's running on board the boat, is taking any streams of data that it has available, including, by the way, history. So the patterns, the surfacing patterns of the whale. When was the last time that it was up? Over the course of the past 10 years, what does that surfacing model look like? How long do they stay underwater usually? How fast do they move between surfacings? These kinds of models are also on that computer that's on board. And we are running algorithms that are essentially trying to estimate when will the whales come up and where will the whales come up, such that we can deploy the robots to be in the right place at the right time to catch that surfacing event, because the whales are only at the surface for about 10 minutes at a time. And so when the whale surfaces, the ideal scenario is that your robots are deployed already in that area so that they can take video streams. They can understand what are the whales doing when they're at the surface. How are they interacting? Are they interacting with each other, or are they by themselves? And what vocalizations might you be able to collect as well? And so all of this data that you're gathering when the whales are under the water and also when they're at the surface are all going back to be essentially processed to understand from a global view more about the behaviors of sperm whales.